So in the previous session, we have just now discussed that a binomial variable. Remember, in statistics, sometimes variables are also called as variates. Okay, so sometimes I may use the term variate. So don't think that you do not know the term. Actually, they are synonymous to one another. So suppose you have a binomial variate, and we have come across that its probability mass function is given by this law, ncx p to the power x q to the power n minus x. Okay, and p plus q equal to 1, and x is taking the value 0, 1, 2 up to n. And for completeness, we always write it in the following manner, because after all, it is a function. And so we are writing this in a functional form. So we know that if x is a binomial variate, then its probability mass function is given by this particular formula. But what is the point of all this? I mean, I started with a coin tossing problem, and then I found its expectation, and then I found its mean, and then I found its variance. Then I try to find out whether this part out of this particular formula, out of this particular probability distribution, can I give a formula to the given probabilities, and I then dissected that probability. So what were my steps? We considered a problem. We did a kind of research work over here. We considered a problem. We found probability distribution. In this case, it was discrete. We found expectation. We found variance. We tried to find a probability law which can define the system. We ultimately found what sort of probability law is this? What sort of probability law is this? Okay. Now, to see that what is the motivation behind doing all this? Is the formula that is actually in front of your screen right now, is this formula always related to coin tossing problem? The answer is no. This formula is not related to coin tossing problem always. This formula is related to any system which will behave in a similar in this particular way. Today I'm not going to discuss any other examples. Tomorrow we have a class, we can discuss other examples in binomial probability law. But right now, to summarize the thing is that I'm just telling you the motivation. Okay. Motivation is that I have got a probability, a kind of probability law, depending upon some conditions. Conditions are that we are actually dealing with for individual tosses. We consider the coin to be fair, and then we called that the trials are independent of one another, so that we can apply the multiplication theorem of probability. And we are very much familiar with what sort of success is actually defined for the system we are working with. What is actually how success is defined over here, and how failure is defined over here. Do we know their probabilities for individual case? We have all judged these particular points, and after this, we try to find out the probability law that the system is actually following. This coin tossing system is actually following. Now, once we get this particular law, ncx p to the power x q to the power n minus x, our next job is to keep it in mind. And whenever a problem is given to us, we will try to see whether all these scenarios that we have considered, all these conditions that we have considered to get the binomial probability law, whether it is being satisfied by other systems or not. If other systems are behaving in a similar manner, this other system can be a bomb throwing system, or a kind of examination system, or a kind of any system. These invitees are coming to the hotel and taking their seat sharing problem. any problem in statistics, we will always try to find out whether the system is behaving like the binomial probability law. If it is behaving like binomial probability law, we don't have to calculate the individual, we don't have to consider all possible outcomes, all the 16 outcomes, and find out their probabilities. Our job is actually minimized now. If you can identify the system, we immediately can say that, okay, this system is behaving like binomial probability law, then we have the formula with us. But at this point, the student can ask, do I have to consider, do I need to get the situation and dissect it as you have dissected the coin tossing problem? No. There is an important punchline over here. The important punchline is that in this particular probability formula, two important things are present that we need to know to judge whether the system is binomial or not. One important term is this one. How many times the trials have been made. So how many trials? This is very important quantity. We have to have some knowledge about this. We have to know what n is here. And there is another important quantity, which is actually very important, is small p. What is the probability of success? What is the probability of success? First of all, we have to define the success. And once it is defined, we will try to look at its probability, try to find out its probability. Whereas Q is not important, because once you find P, then automatically Q is known by the given formula. So these quantities, N and P, these are actually called parameters of binomial distribution. Parameters of binomial distribution. So whenever we are going to judge the system, then we are supposed to find out whether we know the values of the parameters or not. If suppose for a problem, the parameter is missing, we can find out by assuming that the system is behaving in binomial way, we can find out the parameter, or it may so happen that the system is not at all binomial, it is behaving in some other way, because binomial probability distribution is not the only probability distribution that we have in statistical analysis. Other probability distributions are there. We will try to look at their parameters. Then, okay, if it is not binomial, it is something else. Okay, so in something else, some other parameters are there. So do we know this parameter? No, we do not know the parameter. Keep it aside. We have another probability distribution. Do we know the parameters from the situation? No, we do not know. Okay, keep it aside. Take another probability distribution. Do we know the parameters? Is it all the parameters of that probability distribution is present in the situation? Yes. Okay, then my situation is behaving just like the distribution number 4. We can apply that probability law corresponding to the given distribution, that distribution. So this is why this type of study is very important. And before I conclude my today's class, another important thing that I need to tell you is that if capital X is binomial variate, then there is a formula which goes like this. It is a theorem, and you will automatically find out, see what is the utility of such theorem. It says that if X is a binomial variate with parameter N and P, with parameter N and P, parameters must be mentioned, then expectation of X, this will be equal to given by the formula N into P, and variance of X given by the formula N into P into Q. Now you see what is the utility of this. We have already calculated for our coin tossing problem the expectation of X. Now if I try to find out the expectation by the given formula, we see that here the number of experiment is 4. Here the probability of success is half. So the expectation is 2. In the previous case, in the previous session, what we did, we used the expectation manually. We calculated the expectation manually by using this uh, explicit formula. But now we do not require this. We can directly get the value 2. We want to calculate variance of x. Then we need to apply the formula NPQ, which is 4, which is multiplied by half, which is equal to 1. We don't have to apply the formula which is given by Vx equal to E of x squared is equal minus E of x whole square. This is the objective for which we actually study with how the system is behaving. If we can identify the system, we can know its mean, we can know its variance, and so on and so. If you ask me that how this formula do we have to go for the mathematical deduction of this formula? The answer is yes. This is in the syllabus. We will be discussing that in module 4. But since hopefully you are sitting for online examinations in this semester, I think so, then deductions like kind of thing or proof of the theorems kind of thing will not be there in the examination. Short problems, short theoretical questions can be there. So I will show you how to deduce this type of formula, okay, how to evaluate these parameters, but you will see and you can forget. That do not have any utilization. Okay, you as an engineer, you need to know the system, you need to understand the system, and then you have to apply the probability law to the appropriate system. Suppose there is a transmitter which is transmitting the bits of zeros and ones, a sequence of bits of zeros and ones, and your receiver is receiving the bits one after another. Now this receiving and this transmission, and you are measuring this transmission of bits for a couple of times. If suppose this is the, very roughly speaking, if this is the physical situation, then you have to find out what sort of physical situation is this, because bits are very random. Suppose it is coming from some extraterrestrial kind of thing or some other kind of transmission which are not known to humans, and in very erratic fashion the bits are coming, not in regular fashion. Okay, so you are calculating the time interval, the number of bits coming in that particular time interval, and after all, after so many days of so many observations, you will see that maybe there is a pattern. And if there is a pattern, and in this situation, what sort of situation is this? What type of probability distribution is this? So in this particular course curriculum of BSM 301, you will be told about various probability distributions. If few probability distributions are there, doesn't mean that only these probability distributions are there. Probability distribution is a huge topic, and many probability distributions are there. So once you have to do, you need to do something in the practical field, you have to have some idea about all the probability distributions. Okay, some ideas will be or got by you in the course itself. Some you can get it from book on your own interest. Okay, because suppose someone gets into kitchen and to do some things. Okay, so what he or she needs: spices needs, salts needs, recipe need, utensils need, everything. Okay, so for this cooking type of thing. So once you have all these ingredients, then you are in a position to cook something, and you have to know how to cook. If a lemon is given all these kind of things, he can make an omelette with the sugar. Okay, and the pulses with salt, and with no sugar and no salt at all. Okay, so how to cook is very important. Ingredients are also important. So that what I have told you just now, it's the ingredient that you have to keep in mind. Okay, I hope that you will keep it in mind, and I hope that you have understood my today's class. I am ending my today's session at this point. Hope you have enjoyed. See you soon. Till then, bye.